Hey guys. So thank you all for joining. It's this is one of those things that I always look forward to is to discussing. I know it's not an open discussion per se, but we're here to help you. And we're gonna tell you how, of course, our venue, we're known for helping people, and that's our thing. But yes, we are focusing on antenna selection and placement. And really, if you think about it, it's simply the same thing as choosing microphones and placing them correctly, choosing loudspeakers and placing them correctly. It's the same concept because we have stuff we want to bring in or send out, and there's stuff we don't want to come in or send to the wrong area. So let's think of it that way. We're gonna walk through some do's and don'ts, show you some pictures of that too. Um, and then we'll talk. I have a basic like RF rules checklist. It's I call them my three pillars or my three rules of RF, and it has to do with how we troubleshoot, uh, but mostly setting up things and placing them correctly. So we'll fit that into everything we are doing today. But again, we're going to focus on our antennas or antennas in general and how to place them. We make a lot of antennas for sure. The reason we do that is because we feel there's a lot of need for every one that we do. There's gaps and things that some people don't know right away that they can fill. So let's start with the first slide, and I'll just basically say again, we help you make your stuff work. Our venue, our approach is to know what everyone's doing because we work with all brands. So we get into helping you decide how to expand your system, how to set it up, all of the above. And it even comes down to helping you coordinate frequencies. So that's part of the three pillars is coordination. And think of it as if you don't do that right, then you're causing noise within your own system. So let's look at some do's and don'ts. Um, here's a general picture of a setup with ears and mics together. It's good practice to separate them. And it's good practice to keep your transmit antenna for your ears away from your receives. So, although uh, there's many different types of setups with antennas and stages and things like that. So just remember that uh, the rules with ears and mics are important because they both can conflict with each other. Okay, let's advance here. Um, Here's what to do. Obviously you point your antenna where you want it to pick up. If you don't know the front of the antenna, then you're not going to get the signal you want in or sent out. So this is our D fin. The front of the antenna is pointing at the presenters, and that's a fin. It's a log periodic dipole array mixed with a omnidirectional dipole horizontally. And this antenna definitely is one of those that fill in a huge gap that was missing for years. So here's one not to do. Pretend this is your microphone and you wanted to pick up a speaker, someone talking in the same room. Well, this is pointing away from the speaker and it's behind an obstacle. And if you look closely, it looks like there's three cables going into this. It's not patched correctly. So one of those BNCs is an input, then there's two outputs. So who knows? I don't know how this went on this with this exact example, but you could see that the patching was not correct. So yes, a lot of our work has to do with how we use the equipment, patching and signal flow and all that. It applies to uh, this applies the same way as it does for mics and PA systems. All right, another example of our DFIN and our CP beam. Um, the um, they're side by side here. What you don't want to do in most cases is shoot from behind the IEM antenna into the back of the mic antenna. So keep that in mind when you're setting things up. Remember, you have two-way signal going back and forth with mics and ears. Don't point the in-ear antenna directly at the mic receiver antenna. Here's another what not to do. Um, just imagine that you have 20 microphones on one person, um, all going to the same output, and that would not work. You would have tons of comb filtering and poor audio. Same thing with antennas close together, even though they're going to a different destination. Um, these antennas close together are causing themselves to be desensitized, and they can't pick up as well. Picture this as like you have your glasses are all foggy or they're dirty and you can't see well, but you can kind of see, but this is the result of too many antennas in the wrong position. So the idea here is to reduce them by putting them into a distro and then sending that signal out to each receiver. Okay, uh, this slide here definitely is an important one for all of us at all levels, because we have to always take into account all three of these when we're planning, when we're setting up, when we're troubleshooting, and when we're trying to expand our systems so that they're bigger and more elaborate, and we want them more robust. So just I'm going to spend a little time on this just to remind you how it intertwines with how we pick antennas and how we point the antennas. So the first thing we have to avoid is noise, and noise is simply digital television broadcasted in every city and most big cities, but it still is everywhere in the country. And it's in the same range as our mics and ears. Our pro mics and ears are in the UHF range from 450 megahertz to 608 legally now. And our microphones and in-ears are right there with them. We got to avoid them. That's the biggest obstacle. So obviously there's stuff within our room that we're using our stuff in that we have to be aware of, but that's a little bit down the road. But it does tie into step two. Use the high quality equipment and use it correctly. So know where to point your antennas, know what not to put them next to, know what antenna to use for short distances versus long, so forth. Same thing as using a shotgun mic versus a normal dynamic cardioid mic. You have to just you have to read the room and picture yourself seeing what's best for the room. And lastly, coordination is a very much an overlooked step, and there are ways to do it, especially when you're using in-ears and mics together. You can use a number of frequency coordination programs. We have our wireless system builder, and there's a lot of others out there. Soundbases from Sennheiser sure has wireless workbench. I would highly recommend you getting on all three of them and learn how to coordinate. And if you need help with that, we can help you directly with a Zoom or whatnot. Okay, just a picture of what the noise is. We can't see RF noise. Radio frequency noise is not visible, but when we use our tools like our spectrum analyzers, we can see TV stations, and we need to just simply put our stuff where there's no high noise floor. Every city is different, and the challenge of an RF technician or deployment is to put them in the right place and then ultimately coordinate them together. Why? So let's talk about the coordination thing. When I'm going to go to this slide right now. If you don't coordinate correctly, the closer you get your transmitters together, they create harmonics, and those are called intermods. When it's not coordinated correctly, you're going to put harmonics in the wrong place, and that's going to mess up your whole system. So that's the other noise we're talking about. Now, going back to this slide, this is just a good picture of showing where TV is, where we're going to put our frequencies, and what's around us. Meaning, in the same room, we could have interference from our LED walls and power distros, things like that. Our cell phone network around the country is close to the top end of our range, and it does affect the noise floor on that top range sometimes. So that we have filters that help with this, so that's a good thing to know too. But we are now concluding the three rules. Remember, avoid noise, use the equipment right, which we're going to get into right now, and coordinate correctly. It all ties in to where we're putting things in the spectrum and how we're putting things in our room where our deployment is. Okay, so again, let's talk about antennas and how you start picking them. Well, you got to know how far the user or the transmitter, in a case of a microphone, how far the transmitter is away. So if you're 100 feet away and you're outside, and in this case, this picture, it is behind glass, but the best alternative, or the best option, is a circular polarized antenna. The There are two. I see there's a receiver on the table. I'm not sure what those half-wave dipoles are doing, but ultimately, for an outdoor football field, for for in-ears, IFB, and microphones, you should consider a CP antenna. That the picture you're seeing is a CP beam. The reason is because that CP beam picks up in all angles, and it's not just focused on the vertical and the horizontal. It's mixed on a circular pattern of all angles of waves coming back in from the transmitter. So the CP beam right there. Here's our DFIN. This slide is just basically saying really try to take advantage of line of sight. So sometimes you can't. You get people that walk out of the line of sight of the antenna. But when you do have line of sight and you get it high enough, you can angle it correctly. It's best to come in from a higher point at a 45-degree angle down as opposed to straight across. Okay. Obviously, we are the problem we have with antenna placement and selection is some people don't understand where the antenna needs to be, and we get stuck behind obstacles. There are obstacles that are forgiving. Some glass is not, but metal and truss and solid concrete are not forgiving. So sometimes you have to make your point and say, I need the antenna out where it should be. And then you explain why, and you show them on your even on your receiver, you show how much signal strength is coming in based on your antenna placement. All right. This slide definitely can go pretty deep here because it is what not to do. But let's start with the antennas. Now, simply an antenna farm is not good because remember, even though signal's going to all these other various sources, every receiver is getting a frequency coming in. But what happens is when you put these antennas close, those half waves on the back, they 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 block the ability for the antenna to receive clearly and strongly. It's desensitizing the other antenna. So the other thing is all these antennas are picking up noise around it, and there might be power supplies and things at this on this table that are not that shouldn't be coming into the system. So this is a perfect example why we use distribution amps to reduce the amount of receive antennas and send the signal out to all the receivers. That's the number one reason. Now, again, the other part of this slide is that it's showing transmitters really close together. If you fire those up and your intermod potential is super high, you have to avoid putting things really close together. The only thing you can put close together are in-ear transmitters in a rack, and that means, well, because it's practical that way. You can't spread them out. So remember, if you consider microphones and antennas in the same world, we don't want to overdo it, or we don't want to be sloppy or messy about it. So think of the same approach. Okay, another thing that isn't talked about a lot, but remember, when you're dealing with a microphone user, a wireless microphone user, they're moving around, and their receive antenna is not moving around. So it's the challenge is the mic's ability to send signal out is their angles are changing all the time, and your antenna is not. So you have to put the antenna in the ultimate place. You have to angle it in the ultimate position, and you have to have it not too close and not too far. All right. Here's some pictures showing you the angle of the transmitter versus the angle of receive. If it's both vertical, then that's the best. If it starts to become opposite of each other, then it's the worst. So that's polarization crossfade. Our antennas generally are positioned at a 45-degree angle. It is even if it's an omni whip, an omni dipole, or a fin, or sometimes the circular polarized antennas, you would put them at an angle if you can, because your ultimate use of your handheld mic are at angles, just like on the bottom picture here. So definitely on a stage, let's say like a band stage, you have your mics and ears by Monitor World, your antennas. You should put them high, like you should at least put them 5 feet above your head and angle them down just slightly so it points at the middle of the stage. Remember the front of the antenna is the highest sensitivity. Another animation here showing the benefit of circular polarized and how when your polarization angle changes, um, it's it's pretty much the same strength on the carrier. It does not move around as much. Some rooms really require this, especially outdoor rooms, because the outdoor spaces don't have reflections helping with signal coming in or helping. Imagine you're recording uh, someone singing, or let's say a drum, like a any kind of drum, and you have a direct mic on the drum and no ambient mics. Well, it's going to sound pretty direct, and that ambient signal does help. It does help in sound, and it does help in RF. The ambient reflections do help the line of sight. It supports the line of sight. If the reflections get too much, obviously it's going to destroy things at that point. So that there's a balance there. Okay. Let's talk about particular some of our antennas. We have our diversity fin. There's two elements involved. It's polarization diversity. So there's a horizontal and a vertical element involved in one spot. So it's picking up mostly all the angles. We have the same format in our diversity architectural, and our diversity omni is two omni elements in one spot. In a minute here, I'm going to show you we have a matrix of all of our antennas, and it shows you the specs. So if you want to look in one area, it's easy to decide what to use off of that sheet. Okay, our circular polarized antennas. Our new one is the CP stage. The benefit of that one versus the CP beam, or the complement, let's say, that they complement each other because the CP stage really shines when you need to be close in proximity to your talent. And it already has a wide pattern to begin with. With the CP beam, you have to be a little bit far away, and it is great for 300 feet or more. Both can work in any. I've had the CP stage work at 400 feet. Um, just keep in mind, there's the CP stage is IP rated. It's weather resistant. The CP beam technically is not, but there's a different application in most cases. Sometimes I've even mixed the two for mic receive when someone has to be real far away and close. Um, Again, we could talk about those specific examples later if you like, but there's many applications that spur off of this slide that really it's a case by case, and it's not one antenna does all things all the time for every situation. So keep that in mind. The CP architectural is a very nice addition because now we have antenna format that can be hidden within the material of the building. You could paint this with the non-metallic paint. It could hide very easily, and that is definitely appealing for those who don't. And I don't want to say they don't care what the antenna is doing, but they're more concerned with the look of it. That's the thing that, as RF technicians, we have to deal with is sometimes people don't want to see the antenna. Okay, so another just overview of where the front of the antenna is, because we need to point it in the right place, just like our microphones and our speakers. If you don't know where the front is, you're basically reducing your system's performance by quite a bit. Remember, the idea is to to point the antenna in the average area of where everyone's going to be using the stuff. So if you were at Monitor World, you point in the middle of the stage and in between downstage and upstage. If you're on a football field and you have a DFIN for maybe a smaller or a basketball court, you would, let's say a basketball court with a DFIN, you point it where the talent's going to be at. If they're only on one side of the field or the court, then yeah, you wouldn't point it in the middle of the field. You'd point it directly where they're going to be. All right. Another some pictures of aiming and pointing. Just remember to keep your IEM antennas from pointing into your mic antennas. Sometimes you can't put them high, but do your best to get antennas higher than your head and pointing out at a 45-degree angle. Uh, at the end, this line here does say cable length. So knowing your cables is important too. That's remember that's rule 2 in the rules of RF is to know your equipment. You have to know how much loss you're getting with your cables, and when you match that with your antenna gain, you're basically following signal into your system um, for mic receive especially, and if you do just basic signal flow knowledge, you're knowing what strength is coming in based on your sensitivity of your antenna and the cable loss. Okay, here's some more. On the left is our architectural antennas, one D arc and one uh, CP arc. Very, people just love the way they look. The right picture is the new CP stage for mic receives. Um, remember, these antennas have been really taken off because, of course, the weather resistant part, and they're very small. They actually for touring they could pack really easily. So there's a plus plus in that one. Another picture of CP stage, probably IEM in this point. Point it where you want it. Point it where you want the coverage. Same thing with the stage here. Now, the bottom line is you point everything right, you use all the equipment right, but the main thing is you have to walk test it. Walk testing is your final say in how it actually reacts to the room. Because there are times where a certain antenna won't perform like you thought it will, and then you pull out another one. So I would recommend, if I were to give you one general message, is to have a variety of antennas if you can, just like you have a variety of tools in your toolbox. You carry around a variety of mic capsules, cardioid, supercardioid, hypercardioid. You use shotguns for certain things. You don't use them for certain things. That kind of thing. That kind of concept, that kind of approach will help you get out of a bind if you have just a room that's not predictable or working with you. Okay, I'm not going to go through each one, but we've already seen pictures, but just take a look. Um, Polar pattern and sensitivity um, are on these. That you can go to our website too to get more information. Just I would suggest again, get familiar with our models because you might start collecting a few just in case you have a gig that needs something. Just like you would with any other tools. Here's our CPs. Um, really compare the difference between the CP stage and the CP beam and understand the need for both. Okay, here's a slide saying it's going over again why you would choose a CP beam if you're going over a long distance. Sometimes, here's a good example. If you can't run your ears, if you're at a church or a theater and you can't put your in-ears on the stage and you're shooting from front of house, well, yeah, put the in-ear antenna up high, shoot at the middle of the stage from across the room if you have to. But that CP beam is definitely the appropriate one. For microphones too, if you have to shoot across the room or receive across the room, just put them the appropriate height. All right. So I'm going to go back to the slide that explains the three rules because I want to make sure we all know that when we're picking antennas, you are trying to predict how they're going to perform. You're gonna look at the room. You're gonna look at how far you are, how far your cable runs have to be. All this is a checklist. And yes, you put up your first set of antennas and you avoid TV, but then you might have to change things based on a walk test. That's totally normal. Now, if you're installing stuff and it's not a temporary show, you may want to do a site survey. Go out there to the room, get a scan with your spectrum analyzer, take a system with you and walk it with a normal antenna and just walk the room. Some rooms are just not predictable, but there are some that are. And for certain, if you need help with picking antennas in the future, just give us a call. Um, we'll walk you through it. We'll help you be at ease with this. But just remember, if you follow these rules, you're gonna start to become more confident in a lot of things too. All right. So, any questions, Adam?
Yeah, absolutely. That was great, Richard. And just to let you guys know, we do have a new premium ebook coming out soon that covers a lot of what Richard said. So keep a lookout for that. It's very exciting. We like producing all these educational content pieces. Makes it really easy as a handbook, so to speak, when you're out in the field. So I'll start with the first question, which isn't really a question, but more of a statement. Better IEM management.
Okay. By the way, this is not. I don't look like Bob, so this is his picture twice. So it's okay. uh, okay. So if
Yeah, you were supposed to put in your
I
photos.
I know I know. Yeah. Okay, so if we want to improve our ears, here's my suggestion right away is you have to coordinate them correctly. The numbers, because they're so close together, if you don't coordinate them, remember step three of the rules. If you don't coordinate them in a certain manner, and it's all how you use the coordination program, you're fighting your own battle if you don't, because all that energy is so close to each other. When you fire everything up, you're 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 creating your own problems if you don't do the coordination part. And then I'm strictly talking about analog ears. Analog ears are great. The traditional ear system is a 200 kilohertz wide analog FM system, and it sounds great. There's no latency. It's been out for years. They're going to stick around. Now we have technology coming out that is moving past that a bit with the WMS items. But with in your current in ears, um, even separate them from your mic rack, and coordinate. If you need help with this, we can help you through the coordination step. But when it comes to the antenna of an in-ear system, you you may bounce between a CP beam and a CP stage, depending on the size of your venue or if you're outside. Um, it's something you just need to be prepared to figure out on the walk test. The walk test is everything. So here's a tip for one more tip for if you're doing a walk test with an in-ear system, have the engineer put music through your in-ear mix and mix the vocal mic with it. But now you're testing the vocal mic and the ears together. You know now if you hear a dropout with your mic and the music's going, you know your mic is suffering. So you got to start with the distinguishing step of if am I getting problems with the ears or the mics. All right.
Great. All right. Next one is a really good one. So, antenna placement in high school auditoriums to cover the auditorium, stage, backs, and backstage. Would you need two zones for this?
Sometimes, yeah. And so let's say some people are concerned with a basketball hitting the antenna. So they put it behind an obstacle, which is only good if you do it a certain way. With there's a clear plastic dome you can put things behind. But then you also have our CP stage and our CP arc and architectural antennas, which they're very flat. They can take a hit from a ball as opposed to an exposed antenna. It may not, you know, you can't just get a direct hit a lot, but it'll help you be able to put it out where it should be. And if you talk about a basketball court or a gymnasium, well, where's the sweet spot of the room? Where can you hang it that it covers the area that you want? If you don't need the whole court, then figure out how to aim that antenna to where it can be. So definitely ceiling mounted or somewhere on the wall that points in that direction. Now, if you have another zone, we make so a zone would be an area most commonly described as an area away from the room that you're talking about. So meaning separate, and there's obstacles in between. There are some times where there's a really big room and you create two zones within one room, but you have to be careful with that. But the tool that we offer is our four zone piece. And let's just say you hook up two sets of antennas coming in and you test it. What our product has built in is attenuation. So it basically means you offset the zones to each other, so it creates unequal energy, meaning you don't want them to be fully wide open, equal, because what happens when you walk in the middle of the two zones, and if they're sharing energy, the mic will drop out. So if you want to understand the zoning thing, just remember we have people putting zones in rooms that have temporary walls that pop up, and they're technically separate rooms, but they share energy, and they just tweak it with the attenuation in the four zone. It's an easy process. It's a very streamlined piece, but I would recommend buying that if you certainly want the best coverage for both zones. You just have to dial it in.
Excellent. We've got some questions coming in. Tips for placement relationship of transmitter and receiver antennas on a portable sound card.
Okay. Yeah, that's a tough one. As long as it's not, I would say put them left to right. And if the cart is super narrow, then yeah, you just have energy right next to your mic antenna, and that's where a filter might help. You put filters on your mic receives. It's going to help with energy around you. That's probably the number one recommendation. But sometimes you just have no choice. Maybe if it's a cart, you have the ability to put that in your antenna on a mic stand away from the cart, and that's the only thing you get away from the cart.
So
We get these. Yeah,
I can add a little bit to that because I know some production sound mixers who have poles on, like the far corners of their cart.
yeah,
They put a diversity fin on one pole and they put a CP beam on the other pole. And now, they're separated by like, about maybe 18, 20 inches. But they're using the B fin for the mics and using the CP beam for a camera hop so that the camera wherever it's located can pick up audio and record that also.
yeah. I mean, so what we're saying is it's not ideal, but it does work. And what makes it work better too is if you do your coordination step right.
Hmm.
When you do step three right, you're creating a better noise floor for your whole system. So that means your two antennas are not fighting each other as much. You have to keep that in mind.
Great. All right, moving on here. This is a very popular question lately. Can you use the RF venue combine 8 with the newer Axient IEM system?
Yeah, the rule is, and we've had discussions with Sure that you uh, you you can if you're in analog mode. Um, and the word is that they're pushing people towards their new combiner just in general, so there's no in betweens. But analog mode, yes. Our antennas, our CP stage can work with any mode in the new PSM because it's normal. It's just RF coming out. Um, but just keep in mind the combiner thing. Uh, it's brand new. We've tested it. We're going to keep testing it. We have other people that are going to keep giving us information. But right now, just plan on if you have to go beyond their internal combination schemes that they have built in, steer towards their combiner. Just keep us in mind for analog mode for their PSM and all the millions of analog FM systems that are out there now, which is they're not going away.
Great. All right, moving back to the pre-submitted questions. What's the best approach to prevent wireless IM signal dropouts from my singers?
Okay, first thing is avoid noise. So make sure you're on the right open TV channel. Always. So invest in a spectrum analyzer or use Soundbase or Workbench to borrow someone's uploaded scan to make sure you're on the most open channel. That is a skill that everyone who touches RF, who deploys it, has to know for sure that in the city they're in the most open channel. And especially if you're outside. If you're outside the building, or just in the open, you really have to know this. I have a perfect example. Stadiums where the mics and the in-ears are good inside, but as soon as you take the gear outside, it completely is another world. So get that down, put them in the right place, coordinate the ears 100% with the most robust. The settings on the coordination programs we can go over with you, but you have to know that the differences of them because when you calculate frequencies, the settings are giving you more spacing and more robustness, meaning that you can fire a rack of in-ear monitors or transmitters up and not worry about intermods as much. So step one and step two for sure, or step three.
Excellent. All right. Here's one coming in just now. If you use the CP stage outdoors to cover a football field for the ref mic, are there any ways to permanently mount these?
Yeah, so it's a 5/8 thread. There's a couple cool mounts out there that have flanges that can screw into whatever. K&M makes one. A temporary setup or even permanent magic arms are nice from Manfrotto because you can angle them uh, in many ways. The K&M one is has a swivel at the end, so you can angle it right. It's just that the mount is screw only. The Manfrotto magic arm is a clamp. So with either way, you just need to make sure you safety them so that if the mount fails, then you don't drop the antenna.
Great. Yeah, that's a very common ask.
Yeah.
Next one. What to do in high RF use venues to avoid interference beyond the basics?
So the big one is you if you're going into a building that's new to you, you ask questions. You may not be told who else is using stuff in your building with you, and you have to seek out this information. Your job as an RF technician is to find that information because people are relying on you to take care of it. And if you don't seek out other users, that's the number one thing. Um, but know what's around you within let's say 1,000 feet is our common like radius of what's around you that you need to be aware of.
Great. Can you use the RF Explorer to measure the efficiency of each antenna in a particular install?
Yep. So if you're talking receives, you can if you're talking measuring the output of antennas for receive, you could tap into it right after the cable run or at the output of the distro if you're using a distro. Um, the key is if you want to know what the antenna rig is doing based on the way it's deployed or mounted, yeah, tap into it and you could see level coming in as opposed to using your antenna. If you have a spectrum analyzer like RF Explorer, measure it with the antenna on the RF Explorer, compare that trace to the look of it getting signal directly from the antenna rig. If that answers, if that's what you're pointing at is, or if that's what you're asking, then I would definitely compare the two. Um, you may have a bad cable. You may benefit from having a filter involved. There's a whole bunch of variables there. But the way to tell for sure is how it looks on the screen.
Great.
Yep.
This one is definitely less common, but we get this question a lot. Uh, just talk about antennas over fiber distributed in a large space like a casino.
So for microceive, getting if you're talking multiple zones, keep in mind if you do fiber as your main zone, like if you just have one set of antennas out and you have fiber, you have to consider the difference of that with having the rack nearer to the room and using coax. You want to kind of lean on coax as a default because there's less, they're not moving parts, but there's less circuitry in between. If your main zone is coax, let's say in most cases, and you start to expand and you have to go to fiber, the rule is in a fiber set, in a fiber for A and B, um, most of the time you have two sets of fiber. If you follow the signal in, you choose the right antenna, you put a filter before the active fiber transmit part of the set. It's good to, in the case of fiber, it's good practice to put the filter right in front of the fiber transmit because it's an active device. You want to hit it with the best, cleanest signal right there. And then
Great.
when you get to the rack, um, it simply plugs into the distro input. But if you're not using fiber and you're using all coax, you could put filters at the rack if you wanted to.
Excellent, excellent. So this is a pretty straightforward. How to eliminate dropouts in a crowded gymnasium.
Okay, just again, make sure you're tuned right on the right channel. Pay attention to DTV. If you need help with this, I could guide you through this on a Zoom for sure. But the easiest way to find out where TV is to invest in a spectrum analyzer or start using Soundbase or Workbench because you could pull in other people's scans to see that. So start with that. You put it in the right place. You put the antennas in the right place. This is what the whole talk today is. Where should I put my antennas? Well, put them where, just like a microphone or speaker, where you want it to work the best. Avoid noise, and then ultimately coordinate correctly. And the coordination step we can guide you as well.
Awesome.
Mhm.
How to connect multiple antennas for a large RF coverage.
Okay, just for review, if you're talking in one big room, it gets tricky because you don't want to have two sets of antennas at equal strength coming in. Because what happens when you get in the middle of the two sets, like this, just imagine a stadium and you're at one end zone and you put another pair at the other end zone and you walk in the middle of the field, where the ref talks. Well, that's going to drop out because you're in the middle of two sets of A's going into one port, and you're in the middle of the B antenna going into the two B's going into one port. So you offset them. So ultimately, there's other ways to do this. Just to mention the quadversity from Shure and hexversity from Sound Devices. There's ways to get coverage out there with not technically making it multiple zones. So again, you could do multiple zones in one big room with our 4 zone. You have to dial it in, and we're very cost effective in that sense. If it's separate rooms, it's easier to dial in because the room separation is helping you with that offset naturally.
So to
So
follow up on that, Richard, when you
yeah,
say manage an offset, do you mean using the 31 dB stepped attenuators on the
yes,
4 zone?
yes,
And so you would simply turn one antenna down to avoid negative interaction.
yeah, just by minimal sometimes 60 B maybe at the most, and
Gotcha.
you're picking your spot where it actually is in the middle. You want that middle to be away from your main coverage area.
Gotcha. And you can also shut the zones on and off as
Yep. Oh,
needed
there you go.
too.
Yep. Yep.
Yep.
Just definitely the right way. Just like a normal event, let's say a sporting event, you have sound going through the whole bowl. Sound's going through the club spaces. It's going outside. You're there muting and changing signal going to wherever zone you're talking about as the show goes. So RF should be the same way. You're managing it as the show goes. You should consider controlling it as the event's happening.
Great. This is a great one for you, Richard, that just came in. Recommended tips, tricks, and antenna for hunting down late ad arriving ENG crew or other non-communicated production elements with RF usage.
Yeah. So so when that happens, okay, here's an interesting thing. Now, if you're talking about an event, it's a sporting event where you get a lot of ENG people last minute. You have to physically walk there and find it. I wouldn't rely on sitting at your post and having your spectrum analyzer tell you, "Hey, there's." I mean, yes, there's times. So, okay, here's another way to look at it. Let's start with this. You have to memorize all the frequencies that you're focused on, and you're bouncing through them one by one, looking at your spectrum analyzer. You see something pop up, and this happens. You're going to see things pop up, and you go, "Well, that's not what I accounted for." You focus, you put your center frequency on that, and you start walking around. And the antenna you use can be a circular polarized. It could be directional log periodic. It could, it could be our DFIN. It could be an omni. Sometimes you walk around with an omni antenna on your spectrum analyzer, and you just walk where the signal gets stronger. But what helps you with that before you get to that point is you're walking around, and a perfect example is on soccer games where the ENG people start to collect on one of the sides of the field, and they're shooting towards the field. They're doing news related things, and you see little receivers on top of their camera rig. Well, go talk to them. That you're not gonna. It's interesting once you get to that point. You're gonna see that they're gonna they may be telling you that they may not be telling you the truth, or they go, "Oh, I didn't know I can't use this," or you basically get out of them. Well, I'm going to come back and check on you, make sure you're off, or I coordinate your frequencies. It gets a little interesting and fun, but you have to physically get there and introduce yourself and remind them that if they interfere with the event, they're they're going to cause problems for the event. It's not just them; it's the other people.
So
So
when you think they're lying, is that when you pull out the RF Explorer Pro from behind your cloak
yeah.
and see what they're doing? Okay.
Yes, I've had okay, I have an example here. I had this is at the press box level. I saw a signal and I was right next to him and he said, "No, I'm not doing anything." And he had his bag there and he put his hand on his bag and just kind of moved it away. His backpack. So he had something tucked away. There the example is the press level, they're not supposed to bring wireless up there in general. They're told not to. Depends on the event, but I physically saw him kind of push the bag away, and I was looking at the bag. I'm like, okay, I'm gonna come back, and I came back like 30 minutes later, and it was off. So
Interesting. Well, that's yeah, on the fly coordination, always fun.
yeah,
So now we got some more really good questions coming in here. So how much loss in RF strength happens when splitting an RF cable? Does it depend on the cable? Does it depend on the splitter or both?
if you're talking receive coming in, there a common thing is to use a 2x1 as a splitter to take one antenna to go into two input ports of a receiver or a distro. Um, Usually, I'm sorry, two receivers if you don't have a distro. And there's insertion loss in those devices, but it's very minimal.
I
When
think
you're
it's 3 dB with the 2 by
at
one.
the most, yeah, the good ones are less than that. Like ours is less than that. Um, if you're going the other way with IEMs, they have the power going. If you're splitting the signal out of an output of an IEM transmitter, it's cutting the power in half. That's a simple way to just to say it. So if you're at 100 milliwatts out and you go to as a 1 by 2. And the thing is, if you split an IEM signal, you have to have those two antennas in separate zones. They can't be close to each other. So maybe a perfect example is a theater with a green room tucked away in the back. You use coax to get to both locations, and you start at 100 milliwatts. It now is 50 milliwatts in each area.
Got it.
So that's the
Um,
basic way to look at it.
Great. Which antenna is best for outdoor stadiums?
So for definitely mic and in-ears, CPs are very ideal. They've been out for a long time. Um, we've added a couple to the mix recently. There's a standard helical. Our CP beam came out a while back, and now we have our CP stage. The reason is the circular polarized just strengthens the line of sight enough that you don't have to rely on the reflections to help you out. An outdoor venue, there are barely any reflections helping you out. So putting your antenna line of sight and using the CP antenna, the proof of this is if you walk the mic out and you cover the antenna and you still get good signal, well, the CP is doing its thing for sure. Um,
Very
so,
cool.
yep.
Yeah, if you guys go onto our blog, you'll see a lot of case studies about bigger projects in stadiums like Tokyo Olympics. For example, they use, I think, 6 CP beams at the Tokyo Olympics to
Mm,
cover 72 channels of wireless mics in a 3 zone configuration. So, and one thing I've noticed about the top RF guys, Richard included, they tend to like CPs a lot in these outdoor projects for reasons that he explained. So, definitely take a look at our CP series. Now, this question
yep.
is really good because we get this a lot, and I'm not sure it's possible. You guys tell me. When will we see Cat 5 replace BNC cables?
Well, it's already here. Oh, you want to say something?
No, I just think that it's not going to be really viable for conveying RF. Um, yeah, you can do like gigabit, Ethernet over like Cat 6, but that's really not the same thing as sending analog RF. Um, it's achieving that would be a challenge, and I don't know if it's really practical.
Well,
Yes.
That's my
the
point. That's my
yeah, I
point.
mean the world we're in now is that we are getting people to put their radio portion of the system outside of the box. So that means they're sending data to the radio where the antenna is. Basically the radio is part of the antenna. So you call those transceivers in some cases. So the category cable is simply just sending information from the base station. And the perfect example is Sennheiser Spectera. All the intercom companies do the same thing. They're sending data over to the transceiver. Um, so Riedel, Clearcom, Pliant, all them. Um, but but if you notice, Sure's Axiom PSM, it's BNC RF going out, so the radios are inside. There's a trade-off. There's an advantage of each one. Um, you just have to pick your flavor and know what the advantages are of each one. And I would now we're in a position here where we obviously, if you're on a Ethernet or category cable, it's a networked device now, and you have to become very uh, you know savvy at networking just as much as RF these days.
Yes, and to your point, there's some type of proprietary conversion technique that they're taking the analog signal over the Cat5 cable because it isn't feasible to run radio signals 300 feet or more over a Cat5 cable. So it's just not going to happen as simply as sending an audio signal over a Cat5 cable. So that's while you can do it now with the technologies with audio, it's simply not possible with universally acceptable for RF.
Yeah, even the category has limits. So category cable 300 feet before the packets start to lose, but then you go over fiber. That becomes the fiber part makes it where you have a little bit of advantage. But honestly, if you do your RF over fiber, it's the same thing. You're you're converting it to go longer distances. So it's you can go longer distances in both cases. It just you have to there's two ways to do it.
Great. I sent a link to our Optics 3
Yeah.
system, our RF over fiber system. Many customers use this, especially in those big projects that need large areas of coverage, like
Mm.
casinos, multi-room facilities, different floors and buildings. You can take that over single mode fiber up to 5 kilometers. So it's a really great solution.
Yep.
You'd have to hire some angry guys to pull a lot of cable in other situations. So we like the optic system. So that's all the questions we've got coming right up to the end here. Are there any other questions you guys had while we're live? Looks like Bob has answered a lion's share of these questions.
Yeah. So believe us, just hit us as much as you want. Bob and I and Don will all of us will help you. So our company's known for just helping people out in a good, timely manner. So bring it on.
Yeah, of course, you can always email us all, the whole team at info@rfvenue.com. And certainly subscribe to the blog so you can get all the updated information from the guys. We do have one last question for you, Richard.
Mm,
Can you explain the squelch setting?
okay. Yeah, it's think of it as a gate. It's you're changing the threshold of the ability for the receiver to bring in signal. So if you're lowering the squelch, you're technically raising the threshold, which increases your range, but it also means the potential for other stuff to come in. So there's a balance there. And if you're raising your squelch, you're lowering your threshold. Think of it that way. You're letting less stuff in, you're reducing your range, but now that what you don't want to do is, in a sense, have a transmitter off and the receiver is technically open or potentially can be open so that if you're tracking it on the console, now you have a potential for a blast of noise to come out. Now, the workaround is that people have made tone key squelches where the transmitter is sending two tones or one tone as well to the receiver. If the receiver doesn't see that tone key, then it'll mute. But I would not fall back on that as a safety. I would always, if you're going to turn off a transmitter, the person mixing the mic coming out should untrack it or mute the channel. It's good practice. But Squelch has been around forever. The very simple way to see this is on your CB, if you've ever used a CB radio or any even just a
Ham radio.
scanner. Yeah, scanners, hammered.
Yeah.
You dial it in because you don't want it wide open.